Hello, my name is Câmara, and I will present to you the paper called Decision-Making Method for Application of Underground Technologies in Porous Geological Reservoirs. In energy transition time, we need to think on local solution with global spread today, applying them today if possible. Stimulate the increase of smart energy solutions have become one of the main challenges for a sustainable world. The integration between several options of renewable energy generation and its storage, besides the integration with non-renewable generation, is part of this reality. Hydrogen and the other gas are considered as one of the more important options for the energy transition and the green economy. In this research, where we studied the following technologies: underground storage gas technology. They are related to gas injected in geological reservoir with energy storage objective. The initial concept was using the geological reservoir for seasonal gas storage. Enhanced oil recovery with carbon dioxide, carbon capture and storage, and compressed air energy storage in porous media. In this technology, the ambient air is compressed and stored under pressure in a geological reservoir. When electricity is required, the pressurized air is heated and expanded in a turbine, driving a generator for power production. The underground technology can become an excellent option for renewable source support. However, the choice of the best underground technology need to be assessed in a case-by-case, and in this selection, the local and the regional aspect need to be considered. Besides that, the participation of the civil society, private sector, and the academy is essential for the best decision to be made by competent authorities. The analysis of the prospective technology are more complex. The objective of this work is to describe a specific decision-making method for the use of geological reservoir, considering the possible future use. The decision-making methodological concept proposed consists of three phases. A case study, reconcavo base, is then developed and evaluated. For the development of the underground technology decision-making method, a literature review was performed, after which the theme's structure and parameters and criteria were established. In total, 7 themes were identified. In support to these themes, 3 important aspects were recognized: regulatory, governance, and technological evolution. The figure illustrates the conceptual model. The process of the underground technologies evaluation needs to consider the regional aspect, and the tools must be adaptable for each situation. The method for data getting can be simple and dynamic, such as surveys, interviews, meetings, workshops, focal groups, among others. To support the decision, a continuous evaluation of the underground technology state-of-the-art is critical. It is essential to recognize the importance of the underground technology evaluation process and its connection with other phases of the underground technology project's initial analysis. These phases are screen, characterization and ranking, and scenarios. The region selected for study case is in Brazil, on Bahia State, where is located the Recôncavo Base. Recôncavo Base is the oldest sedimentary base in production in Brazil and is classified as a mature sedimentary basin regarding the level of knowledge and exploration. Underground technology tests and application in Recôncavo Base are not recent. The first initiative was in 1987. In the study case, the methodological tools used to accomplish the steps indicated on model were as follows: literature review, participation on events, online survey, expert interviews, and workshops. The online survey had 23 respondents, and it was possible to check the attendance and understanding of the public about undergraduate technology themes' importance. The mostly of the survey respondents were from oil and gas industry. The results were presented to 15 experts from Brazil on expert interview step. Respondents were mostly PhDs and were working in topics related with the themes and the energy sector. In general, the experts agree with the online survey results, but had some disagreements. The main disagreements are concentrated on social aspects and technical themes. The final theme's importance sequence was geology, technical, environmental, safety, social aspects, economy and finance, and infrastructure assessment. This logical sequence must be a guideline for undergraduate technologies analysis application in Brazil, mainly in Salvador metropolitan region. All 47 parameters were identified and 37 directly applied on phase 1. They were classified on go, no-go type or performance type. Go, no-go, parameters and criteria that have established specific values. These values need to be achieved. If it doesn't be achieved, the reservoir is discarded. We identify 18 parameters go, no-go. Performance. These parameters are not critical for underground technology application, but are decisive for make decision. The performance is made by comparative way between underground technologies scores or FIDES scores. Microsoft Excel and QGIS were used, and after analyzing the 5 fields, it was possible to check that 4 underground technologies have potential for application on these fields. The main delivers of this work were proposed and test a decision-making methodology for underground technology. Then, it is possible to conclude that the decision-making methodological concept proposed obtained interesting results. The developed methodology could support the oil and gas operators in Recôncavo Basin for accomplish the Oil and Gas National Agency resolution for fields decommissioning. New phases of this methodology need to be tested, especially for the prospective technologies at early stage of development.